And now we're on to part 3 of our first lecture. One of the things that I've already started to harp on in this course is how important it is that you learn the definitions of things, how important it is that you learn what the meanings of the words we are using are. If you don't know the definitions, you don't know what we're talking about. If I say a word and you don't know what that word means, then you're not going to understand what I'm talking about. I know that I'm giving you lots of definitions at the beginning, and that's tedious and hard, but it's important to be able to learn this stuff. And so we're starting basically from the very beginning. That means I've got to give you some definitions of things, and you just have to learn them. And in this slide, I'm going to give you 2 new definitions, the definition of distance and the definition of displacement. And it's really important that you're able to distinguish between the two, because they can be very similar to each other, but they can also be very different. And if you understand what the definitions are, it won't be confusing at all that sometimes they're the same and sometimes they're different. But if you don't understand the definitions, that'll just get crazy confusing. So let's look at these definitions, and if you have any confusion about this, please contact me and I'll help you make sure that it's solid. Okay, so let's look at this picture here. I've got some guy and he wants to go from point A to point B. Maybe this is his cabin, and over here a few miles away is some general store. And so he gets in his car and he drives down this curvy mountain road to get to the store. And the distance is the length of the path that he travels. And so that is all that distance is. It's the length of the path. Now, distance is what would be read by an odometer in your car, for example. So the car's odometer would read how many miles it is from the cabin to the general store along this curving road. The distance of the road, the length of the road is its distance. Now, displacement is the straight line distance from where you start to where you end up. And so if I'm starting at A and I end up at B, I can draw the straight line. Now you'll notice that I've drawn it as an arrow because displacement is actually a vector. If you start at the general store and you end up at the cabin, you're going with a different direction, and that is important for that displacement. And so displacement is actually a vector quantity. Distance, the length of the path, that's just a number, how many miles your odometer reads. So that's what we call a scalar. Displacement is what we call a vector. And remember, because displacement is a vector, its direction absolutely matters. Now, one more thing that we can talk about, the magnitude of this displacement vector, how long it is, that's also a distance. You could imagine a straight line path from the cabin to the general store, and the length of that path would be also the length of the displacement vector. And we know that a straight line is the shortest distance between 2 points, so that's the smallest distance that you could go and travel from the cabin to the general store. And so there is a displacement which includes the direction, and there's just the distance of this path which does not. And we should note that the displacement vector gives you the smallest distance, and then any other distance is going to be bigger than that you might go on. And in this slide, I've sort of summarized a few of those last points I was talking about. So we can just reiterate here that distance is the length of the path traveled. If the path is along the displacement vector, along that straight line path, then the distance will equal the length or the magnitude of the displacement. Otherwise, the distance will be larger than the magnitude of the displacement. So just FYI. The next 2 definitions that we want to talk about are speed and velocity. Speed and velocity. Now, a lot of people will use these words interchangeably, and sometimes you can get away with that. But again, sometimes you can't. Sometimes they are quite different from one another. Again, that will be confusing. Why is it sometimes they're the same and sometimes they're different? If you don't understand the definitions, then it's confusing. But if you understand the definitions, it's not going to be confusing at all. So we want to focus on these definitions, and I know I'm harping on this, but it's really important that you guys learn the definitions of these things. So we'll start with average speed. And average speed is defined as the distance traveled divided by the time of travel. Now, we've already talked about what distance means. If I'm going from some A to B, I might be going along this curved path, and the length of that path would be the distance. And so what I need, if I want to calculate the speed, I want to figure out, I could use the odometer reading in my car, just measure it out with a ruler or something, but I need to find the distance along this path from A to B, and then I take that distance traveled and I divide it by how long it took to go from A to B, the time of travel. And so the distance divided by time, that's going to give you the average speed. Now, we also saw in the last slide that if I go along the straight line path from A to B, that gives me the displacement. Guess what the displacement divided by the time of travel is going to be? That's going to be the average velocity. So we saw the average velocity is the displacement, that's the straight line path, divided by the time of travel. And the average speed is the distance traveled divided by the time of travel. Now, just note here that when we're talking about the average velocity, displacement is a vector. The direction matters. That means that average velocity is also a vector. In other words, with average velocity, the direction matters. But with average speed, distance is a scalar, time is a scalar, this whole thing is a scalar. That means average speed must be a scalar. The direction doesn't matter. So recapping, the important thing, average velocity is a vector, the direction matters. Average speed is a scalar, the direction does not matter. And again, we have these two definitions that you need to learn. Again, I recommend flashcards. You've got a lot of definitions already. We're going to have some more. You'll want to be able to learn them and keep them straight from one another. Now, let's look at this figure from your textbook. It asks a question. It says, although the car can maintain a constant speed, let's say it's going 10 miles an hour around this circle, that 10 miles an hour is the constant speed, it cannot maintain a constant velocity. Why not? What did we say matters with the velocity? The direction. What do we mean when we say the direction matters? What we mean is that if it's a different direction, it's a different velocity. If any vector quantity, if it's a different direction, it's a different force. In this case, if the car is moving along this path of the circle, it is going that way, but over here, it's going in another direction. Over here, it's going towards you. Over here, it's going away from you. So the direction is constantly changing. That means that at every point on this circle, the velocity is a little bit different than it was before. The speed can be the same, but the velocity is different because with velocity, the direction matters. Now, again, we want to talk about units because units are so important. If I say how fast are you going and you say 12, that doesn't tell me anything. 12 what? 12 chickens? I don't know what you're talking about. But if you say I'm going 12 miles per hour or 12 meters per second, now I know what you're talking about and I can understand how fast you're going. In general, the units of velocity and speed are going to be the same. It's going to be some length measurement, meters, kilometers, miles, feet, whatever, divided by some time unit, seconds, minutes, hours. Some very common units are presented below. Now, I have in here in the SI convention, that's fancy words. That's fancy words for the metric system. SI stands for Système International, which is French for the International System of Units. The SI convention is just the metric system. And so the speed that is usually recorded in a metric system is going to be meters divided by seconds, or meters per second. But there are lots of other common choices for velocity or speed. We can often see it in miles per hour or kilometers per hour, sometimes even feet per second. But in each of these cases, it's a distance divided by a time. Let's do an example. A runner completes 1 lap on a circular track with a radius of 50 meters in 42 seconds. In other words, it takes them 42 seconds to go around the track 1 time. If that's the case, what is this runner's average velocity? What's her average velocity? So let's say she starts right here and she goes around the circle and it takes her 42 seconds to do that. Why don't you pause the video and see if you can figure that out? I mean, seriously, pause the video, stop the video, and get a piece of paper and a pen and work it out. What do you think the average velocity is? We've got a 50-meter circular, the radius of the circle is 50 meters, the circular track, what's the average velocity? I'll pause the video and then come back when you have the answer. Do you have the answer? Did you notice that it was a little bit of a trick question? What's the answer? The answer is actually 0 meters per second. What? How is that? How could it be 0? Well, let's think about it. The runner starts right here, and then she goes all the way around the circle and ends up back where she started. So what's her displacement? Do you see that the distance from where she started to where she ended up was 0? That means the displacement is 0. And what's the definition of average velocity? Average velocity is displacement divided by time of travel. So if the displacement is 0, guess what else is 0? The average velocity is 0 meters per second. Sneaky, right? But do you understand the idea? If that's confusing to you, please shoot me an email and I'll be happy to get with you and make sure that you understand it. But let's move on. And now we can ask the same problem, but we can ask a different question. What is her average speed? Now, speed, we know, is distance over time. So what would be the distance that we're talking about? It would be the distance along the circular path. And if you remember from your high school math classes, the distance around the circle is called the circumference. So that's the distance that we need. We need the circumference. And so in order to calculate, remember that the circumference is 2 pi r. That is the circumference of the circle. That's the distance around the circle. And so this distance is going to be 2 times 3.14, that's pi, times the 50-meter radius of the circle. And when you calculate that all out, you get a distance of 314 meters. Now, in the problem, they told you that it takes 42 seconds to go all the way around, and so that would be the time of travel. And so to get the average speed, and just to be clear, this is the average speed that we're talking about here. I should have put that in. That's 314 meters, the distance, divided by 42 seconds, the time, and we get about 7.5 meters per second as the average speed. Now, the last thing that I want to talk about in this video is the concept of an instantaneous speed or an instantaneous velocity. Now, don't be confused. I've kind of lumped them together there. It's the same regardless of which one you're talking about. And it's simply the speed or velocity of something at a particular instant in time. So let's say again we're going along our curved path, but I start out and I go really, really, really slowly, and then I speed up and I go fast. How would I calculate the average speed? Well, I'd measure out the distance and I'd divide the distance by the time. But that doesn't really tell me much. It doesn't tell me that over here I was going really, really slow, and over here I was going really, really fast. And so I might ask the question, how fast was I going right here? Or how fast was I going right there? At that particular instant in time, how fast was I going? Or how fast was I going over here? That is what we call the instantaneous velocity or the instantaneous speed. And that's what would be measured on your speedometer in your car. It's telling you how fast you're going. When you look at your speedometer at a particular instant in time, it tells you how fast you're going at that particular time. Now, the difference between the instantaneous speed and the instantaneous velocity is just that with the instantaneous velocity, we care about what direction you're going in addition to how fast you're going. If I talk about instantaneous speed, I only care about how fast you're going. Those are the two differences.